Hello students, we are going to start lecture edition. In this class, we have done what is triangle law of vector addition. Over here, we'll do quite similar thing, that is parallelogram law of vector addition. Parallelogram law of vector addition. See over here what we have. Let us suppose we have two vectors A and B which are represented by two adjacent sides of a parallelogram. Then see, let us suppose this is vector A, this is vector B, so this becomes vector A. Then the resultant vector is denoted by the diagonal of the parallelogram, that is A plus B. This is parallelogram of vector addition. It says that if two vector is denoted by adjacent side of a triangle, then the resultant vector is denoted by diagonal of parallelogram taken in opposite order. Then suppose we have to do analytical treatment of parallelogram law, then we will see that this is vector B, this is vector A, and it is quite similar to that we have done earlier on in the case of triangle law of vector addition. See over here, we have said that this is vector A and this is vector B. Angular diagram is theta, component x component is b cos theta over here and b sin theta over here. So this is the diagonal, this is the resultant vector, and it will be equivalent to what? Using Pythagoras theorem. So we will have B, this is vector A, this is vector A. Over here this will be A cos theta, this will be A sin theta. So we have B plus A cos theta whole square, then we have A sin theta whole square, and it is coming out to be what? A square plus B square plus 2AB cos theta, and quite similar result in this case also. When cos theta is equal to 1, the resultant is coming out to be A plus B, and over here theta is 0. Cos theta is minus 1 when theta is 180 degree, and the resultant is coming out to be A minus B, and when we have theta is equal to 90 degree, the resultant will be coming out to be A square plus B square. And suppose we have to find angle the resultant make with one of the vector. In that case, this is angle the resultant make with one of the vectors. In that case, we have tan beta is equal to A sin theta upon vector B plus A cos theta. This is basically parallelogram law of vector addition. In the continuation to this topic, we go for dot and cross product of two vectors. See, when we say dot product, we say it is dot product or the scalar product. The scalar product. See over here, let us suppose we have vector A and dot B, then in this case it becomes mod A into mod B into cos theta. First we have to see, let us suppose general formula we can find it out. Let us suppose A is equivalent to A1i, A2j, A3k, and vector B is coming out to be like B1i, B2j and B3k. See, when we have I dot vector I, it is coming out to be 1. Similarly, j dot j, k dot k are equal to 1. And when we have I dot j, j dot k and k dot I, it is coming out to be 0 because angular diameter, they are orthogonal. I, j, k are orthogonal, means theta is 90 degree between them and cos 90 is 0. And when I dot I is there, they are parallel vector and theta over here is 0. In that case, I dot I is basically mod I into cos 0 degree, that is 1. So we see that, suppose we have A dot B, we have to find out, it will be equivalent to A1 B1, this is A2 B2 and this is A3 B3. And suppose they say us to find angle between two vector, this is A, this is B, angle between them will be cos theta, it will be equivalent to A dot B upon mod A into mod B. In that case, we know that A dot B is what? A1 B1, this is A2 B2, this is A3 B3 divided by root over A1 square, this is A2 square, this is A3 square divided by B1 square, B2 square and B3 square. Now we can say, I suppose it is very clear what actually dot product is, dot product or scalar product. When we have A dot B, that is equivalent to mod A into mod B into cos theta, and suppose we have vector like this, it is going to, we get the result like this. Now we will go for what is geometrical meaning of scalar product or dot product. What is geometrical meaning? Geometrical meaning of dot product. See what we are getting. We say that when we go for the dot product, see this is A, this is B, and angular diameter is theta. We say that A dot B is what? Mod A, mod B, cos theta. Suppose we go for this A and component of vector A in direction B is what? A cos theta. So we say that A dot B is basically what? It is product of vector B. It is product of vector B and component of A in direction of B. This is our dot product. Now we will move on to what is cross product or vector product. See what we have. Cross product. Cross product means we can also say it is vector product. See, we have A cross B is basically mod A into mod B into sin theta. Suppose we have, see over here, we can have terms like this. This is I, this is J, this is K. Suppose we have I cross J, it will be I cross J is K. And J cross K will be I. And K cross I will be, K cross I is J. And see, vector, cross product of vector is not commutative. So we are not going to have I cross J is not equal to K, but J cross I will be equal to minus K. K cross I, sorry, this is K cross J will be equal to JK, this is I, minus I. And we have I cross K will be minus J. So using this thing, what we can have, either we can use this or we can use the matrices multiplication. See, suppose we have vector A as A1I, A2J, A3K, and vector B as B1I, this is B2J, B3K. Suppose we have to do A cross B. Either we can long term multiplication, we can get this also, but in shortcut we can have like this I, J, K we can write. We can write A1 over here, A2 over here, this is A3, and over here it is B1, this is B2, this is B3. Suppose we have to go for I. So when we take I, we will get this matrices. This is I, this is A2, B2, this is A3, B3, and for J we have negative, and this will be A1, B1, this is A3, B3, and we have K. K we have A1, this is B1, we have A2, and this is B2. So what we have, we multiply this to this and subtract this to this. What we get? This is I, A2, B3 minus A3, B2 minus J, A1, B3 minus A3, B1. Then we have K, this is A1, B2 minus A2, B1. So we get the A cross B. And suppose they say us to find angle between them, this sin theta. So we can have this sin theta will be equivalent to A cross B upon mod A mod B. This is our cross product. Now we go for what are the geometrical meaning of the cross product. What is geometrical meaning of cross product?